Hello and thanks for using TickBoom. In this video I'm working through question 4 out of a series of 6 questions that are all concerned with volumes and how we can calculate volume using calculus. Question 4 is very closely linked to question 3, so if you haven't already, definitely go take a look at question 3 as background. Question 4 says, imagine that it is possible to cut open and straighten out the torus to create a cylinder with length determined by the length of the torus along its center line, your E value. Show that the volume of this cylinder is the same as that of your torus, and the torus being referred to here is the one in question 3. So I think to start, let's just go back to question 3 and take a look at what we're dealing with. So the torus that gets formed, it's essentially kind of a cylinder that's been folded in on itself. And so what question 4 is asking us to do is to imagine cutting that cylinder, and then kind of flattening it out. So you don't want to confuse that with this cylinder that we're flattening out. It's actually the torus that we're cutting and flattening out. But it's the same kind of idea. You really need to visualize what's going on. But if we were to do that, what we'd end up with is, obviously, as a cylinder, we'd have our circle at each end. And the length of that cylinder, as the question kind of hints at, is basically it's the circumference of the torus at the center line. So if you kind of picture this center line is what determines the length of that torus, and then these top and bottom lines are kind of what gives the torus that round shape, because it's a circle being rotated. But it's that center line that ultimately determines the length of this cylinder, and we know that that center line had a length from the origin of E. And so the circumference of the circle that gets generated when you take something that's a distance of E from the origin and you rotate that around, that's going to be 2 pi E, or 2 pi R, where in our case R is E. So the length here would be 2 pi E. And we know that this diameter is D. And so we can now work out the volume of this cylinder, and that's a really fast way to essentially do what we just did in question 3 and almost work as a check, another check. So you may remember in question 3, if you've seen it, I did a check using just the generic formula of a volume of a torus, which you may not have learned, but anyway, that's what it is. But now we're doing another check. This question 4 essentially amounts to another check on what we did in question 3. So we know the volume of a cylinder. The volume of a cylinder is equal to the area of the face times the height. In our case, the area of the face would be pi times the radius squared, so that would be pi d squared. And then the height we've just deduced is 2 pi E. So let's bring this together. So we'll get 2 pi squared, and I'll just write, just to have it in the same order, E d squared, and then units cubed. And that's it. That's how you tackle that question. So very short in terms of the working out, but I think all the difficulty of this question really came in your ability to visualize what's happening when you take that torus and you kind of flatten it out. And I think this question would have been quite difficult to, I guess, visualize and get your head around if you hadn't already gotten comfortable with question 3 and what was going on. But the good news is we can see that the answer we got to in question 3 is the same as the answer we get to using this shortcut. So that gives a bit more confidence that we haven't made any mistakes. So hopefully that all makes sense. If you found that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. All right, tick boom.